Okay, so page 29, lesson 4. Like I said, we're going to go over the notes today. You'll have homework tonight. We're doing lesson 5 tomorrow. So today it's on color mixtures. I did realize that I forgot to show you the whole ratio video. Ellie, did you watch the talk? Did you watch that video? I forgot to show that to him, so I have to do that. If there's time, I'll show it to you today. So we're going to skip 4.1. So I want you to turn to the one that says turning green, 4.2. And yours might look slightly different than mine. It's at the bottom of page 29. And then there's some more on page 30. Okay? Yeah, you don't have the pictures. You don't have the graduated cylinders. Okay? Yours says, your teacher mixed milliliters of blue water and milliliters of yellow water in the ratio 5 to 15. Okay, in the ratio 5 to 15. So I'm going to write that up here on the board. 5 to 15. Do the directions say in the ratio was blue to yellow, or it just says I mixed blue and yellow? Okay, so we don't know which one is which yet. Okay, then go ahead and turn the page. It says doubling the original recipe. Draw a diagram to represent the amount of each color that you will combine to double your recipe. So actually, let's go ahead and assign it. What order did it say it in your book? It said blue first. So on page 30, under number 1, go ahead and write this original recipe. Do BL:Y as our generic ratio. And then it's 5 to 15. It should tell you. It would matter to make the color. Do you guys know what color blue and yellow makes? Green. Green. Blue and yellow mixed together makes green. Okay, if I mix this, I'm going to go ahead and show you. So let's do 5 blue. Oops. Oh man, I can't drag it if I'm writing. I'll go ahead and close out of that. I put too much now. Reset. So I have 5 blue and 15 yellow. So 5, 10, 15 yellow. First, how do I know that I have all of my paint that I'm supposed to have in there? Because it was kind of confusing dragging and dropping. Jake?
20 plus 5 equals, or no, 15 plus 5 equals 20.
Yeah, because each one was 5 milliliters. So I should have 20 milliliters, and it shows I have 20 milliliters. Okay? So it wants me to double that batch. And it wants me to draw a diagram. So how can I double that batch? Leo? So let's start, and this is still under number 1 on page 30. Okay, let's start by writing the original ratio, and I'm going to write it as a fraction this time. You already have it as the ratio. Now let's write it as a fraction. I'm still going to put BL and a Y down here so I know which one's which. If I'm doubling it, really we are creating equivalent ratios or equivalent fractions. So what does the word double tell me to do? Ellie? Multiply it times 2. So I'm going to show times 2 times 2. What's 5 times 2? 10. What's 15 times 2? 30. Does it say draw a diagram of that? Whew. Let's do just B's and Y's. Okay, you could do boxes. B's and Y's are easier. So let's do the 5 to 15. So let's do B, 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 B. And we're trying to group it in 2 sets. So then I'm going to do Y's under it. I'm going to do 5, 5, and 5. And that's one batch. How many batches do I need? 2. So now I'm going to copy that. I'm going to leave a little bit of space and do the same thing again. Because you're doubling it. And this is all under number 1 on page 30. Okay, now this is talking about paint. So if you like that ugly booger green color, and you went and you just bought 1 batch of it, 1 gallon of it at the paint store, and you get home, you use that 1 gallon and it's not enough, and let's say it didn't even get you halfway through your job. You're like, hey, I'm probably going to need 2 gallons. If you went back to the paint store and they didn't use this same ratio, it would be a different color, and you'd go home to start painting and your paint wouldn't match, okay? So anybody mixing paint, it's very important to do these ratios. I don't know if you've noticed, but most of this is all computerized now. Why do you think they have computerized this process?
So they can remember.
Not so they can remember. Yeah, because human error is a real thing, okay? Computer error only is there if they type it into the computer incorrectly, which also probably happens sometimes. So I'm going to show you. I'm going to clear my writing up there, so hopefully everybody has it. So on this one, we said it would be what, 10 to 30. So I'm going to do 10 to 10. See how they're not the same color? But each time I add yellow, it gets a little bit lighter. So that's 5, 10, 15, 20, 25, 30. We should, yeah, they should be the same color. Why are there different amounts?
Because you doubled it.
Yeah, because I doubled the recipe, which would double my total amount of paint. Okay?
More yellow in that first.
Okay, if I add more yellow, as I add yellow, what's going to happen to my color? It's going to get lighter and lighter. Okay? What does question 2 say in your book? Or sorry, question B, 1B. Okay, I did that on the board. So we actually did that already. Tripling the original recipe. Go ahead and just write the ratio for tripling. So write our original. This is number 2. I'm not going to make you draw it. But for number 2 on page 30, our original recipe was 5 to 15, and that was blue to yellow. I want you to tell me what it would be if I tripled the recipe. If I tripled the recipe, so start with 5 over 15. Triple the recipe, Dom.
45.
So write it. Sorry, you're down on number 2. We're all the way down on number 2A.
Oh,
2A. Okay, Tatum, what would I have? Yep, because times 15 to 45. How should it compare to my original color, Leo? Yeah, it should be the same, just tripled.
Can we try that? Yeah.
Just add more. Does everybody have that written down? Okay, so if I triple it, what would we, another 5 blue?
It'll just get darker.
Did it go in?
Yeah.
Okay, and then
Make it
15 yellow?
No, just even it back out, yeah. Put one more. Wait, do 100. Just do one blue.
So guys, so it's showing me the ratios. If I click that, that's 15 to 45. That's 5 to 15.
They're like different colors, kind of.
Nope, they're the same.
No, like the left one looks a little darker. No,
It's because it's a smaller amount.
Okay, number 3, go over to page 31. Go over to page 31. It says invent your own ratio. So Dawson, give me a ratio, any ratio.
3 to 6.
3 to 6. 3 to 6. And we'll say this is still blue to yellow. blue to yellow. We're not going to draw it out. I want you to think about if we are comparing that to this one. If we are comparing it to this one. I'm going to reset this one over here. If I were to enter, I have to wait till I close out my marker. If I were to put that 3 to 6 over on this side, how would it compare to this color? So I want you to do the work and decide, is it going to be lighter than the original? This one is the original. Or is it going to be darker than the original? Okay, so first I'm going to tell you, you have to get these two things comparable. Think about how we get fractions comparable.
Just add more.
Mm-hmm. You have to get them comparable. I'm going to help you get started, and you might not have gone this route. There's different ways. I'm going to reduce both of these first. I'm going to reduce them both down because neither one of them is in simplest form. So then think about, so I reduced them down. Anytime you're comparing, you need either the numerators the same or the denominators, one or the other. So we've talked about this with like how it would taste, how would the flavor be affected. Now we're thinking about color. How would it affect the color? So when I reduce those down, they both have one blue. Our original recipe has 3 yellow. Our new recipe only has 2 yellow. So how would our new recipe compare to our old recipe is what you're trying to answer. I want everybody to get something on their paper. Okay, and you can write this anywhere under, where are we at, number 3? Jake, we're over on number 3. Okay, so this one is our new recipe. This one was our original recipe. I want you to tell me, how does the new one compare to the old one? And your answer will be, it's going to be darker or lighter, and give me a reasoning. Darker or lighter, and give me a reasoning. Okay, who thinks they have an answer? Leo?
The new recipe will be darker because if you multiply 3 times 6 both by 5, you can get 15 over 30.
Okay, so you're saying multiply both of those by 5?
Yeah.
We would get, so you change the ratio to 15 over 30, okay?
The 5 15th, multiply them both by 2, and you get 10 over 30.
10 over 30. So you're saying there's only, on this one there's more blue paint.
Yeah.
This one, there's less blue paint. So you're saying the original one would be darker because it has more blue paint. Okay? Raise your hand if the new one would be darker because it has more blue paint. Raise your hand how we could have used that one. Hallie?
I put the new one will be darker because yellow is only doubling the blue, the original is tripling.
Okay, so she said here, she's comparing the 1 to 2. She said yellow is doubling in this one, and yellow is tripling in that one. She's correct also. So regardless of how you did it, it would be the new one will be darker. Because why? There's more blue in it. There is more blue in it. Yeah, or you could say there's less yellow. More blue or less yellow. Okay, so now I'm going to prove it. I'm going to go ahead and clear this. Everybody know what to write there? Okay, so I'm going to do 1 to 2 and 1 to 3. Let's see, original was 1 to 3. So I'm going to clear both of these. Reset. Reset. 1 blue, 3 yellow. Okay, this one is 1 blue, 2 yellow. Okay, and see how this one's just a little bit darker, and it's probably hard to see from your seat.
Not really.
Okay, but that's what ratios affect. Okay, is they would affect the overall color. So if you're adding more of a darker color, the end result is going to be a darker mixture. If you add more of a lighter color, the overall result is going to be more of the lighter mixture. Okay, go ahead and turn the page. Now we're going to talk about the perfect purple something. Turn the page to page 32. Perfect purple water. It says the recipe for perfect purple water says mix 8 milliliters of blue water with 3 milliliters of red water. I'm going to go ahead and write that somewhere. So somewhere around that problem, let's go ahead and put it under number 1. I don't know what number 1 says yet, but you have room right there. Under number 1, let's go ahead and start with a ratio. Let's do, it says 8 blue water and red water. So I'm going to do BL over R equals, what's my ratio of blue to red? What does it say? 8 to 3. So 8, and this is all in milliliters, over 3. So that's my ratio. Jada mixes 24 milliliters of blue water with 9 milliliters of red water. Andre mixes 16 blue and 9 red. Which person will get a color mixture that is the same shade as the perfect purple water? Show or explain your reasoning. How can I check this? How can I see who has the perfect purple water? Hallie? To see if one of them is equivalent. So let's start with Jada. So here I'm going to put equals, I'm going to write Jada above it. What is her ratio of blue to red, Emmy? I'm going to change colors here. Sorry. 24 over 9. Now I have to check and see if she did it properly. Elise, how can I check and see if that ratio is equivalent to 8 to 3?
You can divide the 24 and the 9
Okay, we can, or we can just check multiplication. How do I get from 8 to 24? Times 3, so I'm going to show times 3. If the bottom one is also times 3, that means her ratio is good. If her bottom is something different, will her water match? No. So is 3 times 3, 9? Yes. Yeah, so Jada should be good because hers is just how many batches of the original? 3. Okay, she just had 3 batches. Now let's check Andre. I'm still going to start with 8 over 3. What is Andre's ratio? And sometimes they flip it too. So this one is still blue to red. Sometimes they'll give Andre's red first and then his blue. So pay attention to those labels. But this one is 16 to 9. Okay, how do I get from 8 to 16? So this is times 2. What happened on bottom? Times 3. So red, and that's blue. Okay, so for number 1, which person will get a color mixture that is the same shade? Jada. So for number 1, we're going to write Jada. We showed our reasoning. Jada will get the same color, but she'll have how much?
Times 30.
She'll have, 3 times the amount. And it doesn't ask this, but how will Andre's color compare to the original? If his blue doubled and his red tripled, will it be darker than the original
It'd be more red.
or lighter?
It'd be dark. Depends what color we call light or dark.
Yeah.
There'd be more red.
There would be more red, which would result in a lighter purple. Okay? So Andre's would be a lighter purple. It wouldn't be the perfect purple. It would be a little bit lighter. Yes?
For ratios, can there be anything, any kind of number, just anything to something else?
Yep, it could be a fraction or a decimal as well. Yep,
A decimal?
could. Yeah, because what's half of 5?
Oh,
2.5. Okay, let's look at number 2. Find another combination of blue and red water that will also result in the same shade as perfect purple water. So I'm going to go number 2. You guys have room there. I'm going to go out here. Number 2. I'm going to start with my original ratio. What can I do to get another perfect match? Afton? Okay, times 4 times 4. Times 4 times 4. So 32, let's go ahead and add a label, milliliters of what color? Of blue. And, because we're 12 milliliters of 12 milliliters of red. So really, if you're good at finding equivalent fractions, you can do equivalent ratios. It's the same thing. It's just understanding them a little bit better and how it will affect the overall color or taste if you have the wrong ratio. Once you have that, look over on page 33. Look over on page 33. When we made our model, we just used B's and Y's. We just used B's and Y's. How did they show it? How did they model it? On page 33.
Squares.
Squares, just like we did before. You could use squares, you could use stars, you can use circles. Okay? Notice they showed 1 batch, 2 batches, 3 batches. Are they still, could we have circled the different batches? Yes, so it's just like we did in the first couple lessons.
I thought you said you couldn't do the same shape.
They're changing colors. You guys don't always have different colors. That's fine, because they tell us how to decide what's what. Okay, so they showed batches like that. We could say that the ratios 4 to 2, 8 to 4, and 12 to 6 are equivalent because they describe the same color mixture in different numbers of batches. Okay, your homework are the practice problems.
All of them?
All of them. On number 7. Flip over to number 7, all of them. So it's 1 through 7. On number 7, you can leave them unsimplified. So you can leave them as improper fractions. Okay, you can leave them as improper fractions. So 1 through 7 is your homework. You can go ahead and get started on it. We have about 15 minutes, so you never get this much time, so don't complain.